company wishes to run a television cable from point A on the shore to an installation at point B on an island. The island is 6 kilometers from the shore at point C, and point A is 9 kilometers from point C. It costs $400 per kilometer to run the cable on land and $500 per kilometer underwater. Assume that the cable starts at A and runs X kilometers along the shoreline and then turns and runs under the water towards the island as shown on the diagram. Find an expression in terms of X for the length of cable used. So if that's X, this must be 9 take away X, and therefore this distance here, using Pythagoras' theorem, would be the square root of 6 squared plus 9 minus X, all squared. So the total length of cable used is going to be X plus the square root of 36 plus 9 take away X, all squared. State the cost function for laying the cable. So this part here we know costs 400, so that's going to be 400x, and this part here costs 500, so that's going to be 500 times the square root of 36 plus 9 minus x, all squared. Use calculus to determine the point at which the cable should turn in order to yield the minimum total cost. So we want dc dx equal to 0. It's a horrible function, so let's do it on the calculator. So let's go to main, and I'm just going to clear anything I've got. So action, advanced, solve, 0 equals, and we want to differentiate the cost function. So I'm going to go interactive calculation, differentiate, and it's 400x add 500 times the square root of 36 add bracket 9 take away x, all squared. Close the bracket for the square root, and that gives me x equals 1. So x equals 1 kilometer. State the total length of cable used, so we need to put 1 into here. So that's going to be 1 add the square root of 36 plus 9 take away 1 squared, and we just need to evaluate that, and if we do, we'll find that that's 11 kilometers, and determine the minimum cost. So what we need to do is substitute x equals 1 into this one, so that's going to be 400 times 1, which is just 400, add 500 times the square root of 36 plus 9 take away 1 all squared, and if we calculate that, it's $5,400.